Hi guys, today our concept is how to check the quality of river sand. What do you think is the most essential building material after cement that is used in the construction industries? Yes, of course, it's the sand or the fine aggregates. Why is much importance given to the inadequacy in sand and most construction process are stopped probably due to that at the site? It's because sand is the binding material between cement, coarse aggregates, and water. It also offers strength and other important properties when prepared as concrete. Fine aggregates are classified on the basis of origin, composition, and grain size. It's river sand which is classified on the basis of origin that we are going to see today. River sand is the conventionally used material as fine aggregates. It's a building material extracted from the naturally occurring riverbeds or the riverbanks. The chemical composition of river sand is shown in the pie chart. It mainly consists of silicon dioxide, which has the property of giving strength to the concrete. River sand is mostly recommended for brickworks, RCC, and plastering works. These are the specifications and manufacturing process of river sand. River sand is available abundantly from the nature and the shape and texture provides good workability and highest compaction. Hence, river sand is preferred. To create innovative and durable structures to the world, the quality of the building materials are essential. These are the tests done to check the quality of river sand. The first test we are going to see is bulking of sand. Bulking of sand is nothing but the increase in volume of sand. The free moisture content in fine aggregate results in bulking of volume. Free moisture forms a film around each particle. This film of moisture exerts what is known as surface tension, which keeps the neighboring particles away from it. Similarly, the force exerted by surface tension keeps every particle away from each other. Therefore, no point contact is possible between the particles. This causes bulking of the volume. The extent of surface tension and consequently how far the adjacent particles are kept away will depend upon two things, that is, the percentage of moisture content and the particle size of the fine aggregates. It is interesting to note that the bulking increases with the increase in moisture content up to a certain limit. Beyond that, the further increase in moisture content results in the decrease in volume. At a moisture content representing the saturation point, fine aggregate shows no bulking. As per IS 2386 Part 3, bulking of sand with the presence of 4% of moisture content increases of about 25% of its volume. Second point is that the fine aggregate bulks more than the coarse aggregate. From this, it follows that the coarse aggregate also bulks, but the bulking is so little that it is always neglected. Due to the bulking, fine aggregate shows completely unrealistic volume. Therefore, it is absolutely necessary that consideration must be given to the effect of bulking in proportioning the concrete by volume. The procedure of the test starts with the filling of measuring cylinder with a sample of moist free fine aggregates. Note the level as H1. Now measure it with a steel scale. Pour water into the measuring cylinder and completely inundate the sand and shake it well. Since the volume of the saturated sand is the same as that of the dry sand, the inundated sand completely offsets the bulking effect. Note down the level of sand as H2. H1 minus H2 shows the bulking of the sample of the sand under the test, which can be found by the following formula. The next test we are going to see is sieve analysis. Sieve analysis is conducted to determine the particle size distribution in a sample of aggregate. Sieve analysis is performed with a set of sieves which are of various sieve sizes. The test procedure involves by taking a sample of about 1000 grams of sand using a weighing machine. Pour the sample in the set of IS sieves which are arranged in the order with 4.75 mm sieve at the top and 15 micron sieve at the bottom. Then place the set of sieves in a sieve shaker or gently shake it with the help of our hands. Then, weight of the sample retained in each sieves are weighed in a weighing machine and the values are noted. This table shows the sample of the weight retained in each sieves according to their sieve sizes. The first column represents the sieve size, followed by weight retained, percentage retained, cumulative percentage retained, and the percentage passing. Percentage retained can be calculated by weight retained divided by total weight, that is 1000 grams in our case, into 100. Cumulative percentage retained can be calculated by adding the consecutive values of the percentage retained. Percentage passing can be calculated by subtracting the cumulative percentage retained from 100. The next quality test we are going to see is silt content test. Silt is a very fine material which is less than 150 micron in size present in sand. The excessive presence of silt in sand is very harmful because silt reduces the strength and durability of concrete. To overcome this, we have to perform the silt content test. The test procedure involves by filling a cylindrical jar with 1/3 of sand and 2/3 of water. Then a pinch of sodium chloride or salt is added to the jar. The jar has to be shaken vigorously by closing its mouth with our palms and turning it up and down repeatedly. The mixture is then allowed to settle down for some time. The silt will settle at the top of the sand in the jar. The volume of silt is recorded as V1 and the volume of sand is recorded as V2. The percentage of silt content can be found by the percentage of ratio of volume of silt to that of volume of sand. Silt content should not be more than 6% by volume with respect to total volume of sand. The next test we are going to see is organic impurities test. Organic impurities in sand may be due to the presence of decayed vegetation, humus, coal particles, or any other organic matter that is present in the riverbeds. It is generally considered that organic impurities retard the setting of cement and thus have deleterious effect on the strength of concrete. A simple test for determining the presence of injurious organic matter in sands is made by shaking some of the sand in a plain glass bottle with an equal volume of 3% solution of caustic soda and allowing the mixture to stand for some time. The liquid above the sand should not be a darker than light straw color, that is pale yellow color. If the color is a marked yellow or brown, then it indicates the presence of an excessive amount of organic matter. Such impurities can be removed by washing the sand. Washing has an additional advantage of removing any salts in sand. Apart from these tests, there are also other simple tests to check the quality of river sand. They are test for clay and test for moisture content. Test for clay involves by rubbing sand with water into our palms. Sand with minimal clay doesn't stick to our palms, whereas sand with excessive clay sticks to our palms. Test for moisture content includes drying method and calcium carbide method. Thanks for watching this video and have a nice day.